Hello everyone, we'll be starting with the session now. Hello everyone, good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 8B. Myself Anshika Jain and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundations and GI Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Congress on Information and Communication Technology ICICT 2025 London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 18th February in London, UK, and the virtual event is being held through Zoom from 19 to 21st February 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for this session. First, we have Professor Con John Van Steen. Ma'am is an associate professor at the University of South Africa. Her expertise spans software engineering and UX designer, contributing to the enhancement of digital learning environments. Her research interests are user experience of e-moderation, human-computer interaction, and creating emotional resonant user experiences in open distance e-learning institutions. I would also like to introduce you to our next session chair, Dr. Anubha Jain. Ma'am is working as a director, School of Computer Science and IT, IIS Jaipur, an academician for the last 22 years. Ma'am has actively contributed in the teaching industry and research and development. Her research interests include soft computing, computational studies, law, and software engineering. She is the author of 9 books and has published a number of papers at national as well as international levels. Welcome to the session, ma'am. Would you like to share a quick opening remark with us?
Thank you, Anshika. Thank you very much. At the outset, I would like to congratulate entire GR Foundation team for organizing such wonderful events. And I wish all the best to all the participants who are eagerly waiting to present their research. So I'm very keen to hear to the wonderful research being done by all the researchers around the world. All the best. Thank
Thank,
you.
thank you so much, ma'am. So now I would like to start with the papers. First, we have Yang to present the paper titled 3D Environmental Map for Navigational Safety in Autonomous Ship Operations. Are you there?
Yes, I'm here.
Yeah.
Can I share my screen?
Yes, you can share your screen and you may begin with the presentation.
Yes. Okay. Can you see me? Yes.
Yes, we
Okay.
can see the screen. You may begin.
Okay. Good morning. Thank you for being here today. My name is Ayong Yang, and I'm PhD student at Tokyo University of Marine Science and Technology. I study autonomous ship focused on small vessels that have a higher risk of accidents. In this study, I create a 3D map that combines surface and underwater data. This map helps ships navigate safely and efficiently even in challenging environments. I hope my presentation will be helpful and interesting for you. Let me introduce autonomous ship. Autonomous ships are vessels capable of navigating on their own. The International Maritime Organization defined them as mass and classified their development into 4 levels. Level 1 and 2 ships are already in commercial use. Certainly, countries like Norway, the United States, Japan, and South Korea are actively conducting research and development focused on large commercial vessels. But can the technology developed for large vessels be applied to small vessels as well? At first glance, it might seem possible. However, there are many differences between large and small vessels. This difference includes size, sensitivity to the environment, and equipment installation. Due to this difference, our research focused on developing autonomous navigation technology for small vessels. Let's compare this to something familiar car. While ship and car differ in many ways, the key distinction is where they operate. Cars are commonly in daily life and use technology like lane changing, obstacle detection, and emergency braking. They run on fixed roads and follow lanes, which remain stable except during extreme events like earthquakes. However, ship navigation on water with about one-third submerged. Factors like cargo weight and tide affect navigable paths. So, autonomous ships have accurately recognized both underwater and surface environments, making this a crucial challenge in research. Let's explore how ships gather environmental data. This slide shows the electric chart commonly used on large vessels. It provides information about nearby ships and the vessel's own status. The diagram on the right illustrates how electric charge data can be interpreted. However, since it relies on predicted data, which may not always be accurate. However, in urban canals and narrow waterways, small vessels operate in complex environments and cannot use electric charge, making environmental awareness crucial for safe navigation. To address this, our research developed a 3D environmental map that integrates underwater and surface data, helping small vessels navigate safely in challenging areas. Creating a precise 3D map is a promising approach to enhance that safe navigation to autonomous ships. The process was carried out of the following steps. Step 1, target area selecting and route design. Step 2, navigation and data scan. Step 3, data processing. Step 4, 3D map generation. The test location were selected to address key challenges in navigation and to collect practical data. This urban waterway is narrow and complex, surroundings by building, bridge, and tourist attraction. To create a detailed 3D map, we collect data on water depth and obstacle support navigation in such challenging environments. Pier or docking area for large vessels where the size of the ship and structural constraints create a high risk of accident. We collect data at the pier to record environmental information crucial for safe docking. The marina is primarily used by small vessels such as a yacht and boat. Many users are not familiar with advanced marine technology, which increasing the risk of accident. At this location, we collect data on underwater obstacle and surrounding facility. Let me present the result. Overall results provide a seamless 3D visualization of both underwater and surface environments, allowing them to be viewed comprehensively across the entire screen. This enables precise identification of depth, distance, terrain, and obstacle detail. Various measurements such as length and water depth are intuitively displayed using color and coordinate data. The first result is the Tokyo Urban Waterway. This map provides a detailed visualization of narrow waterway and surrounding structure. It integrates depth variation and terrain information, enabling effective identification of obstacle and spatial limitation even in complex environment. Here are the results for pier and marina. The pier and marina are where ships come into contact with land, making docking area particularly high-risk zone. Additionally, tidal variation change the water level, altering the visibility of structure with require extra caution. The 3D map created in this study is useful not only for ship operate but also for protecting and maintaining pier and marina facilities. This slide shows an example of how the 3D map can be used. To demonstrate how safe in navigation routes in narrow waterway can change depending on time and environmental conditions. For example, during low tide, the water level drop, exposing obstacle or narrowing the passage, while high tide may cover obstacle. The 3D map clearly visualizes this changing, helping navigator identify safe route more efficiently. Next, I'll discuss the key limitation of this study. First, scanning challenge. Obstacle like a bridge pillow and mooring vessel left unscanned area, and the vessel draft restrict access. Underwater drone or ROV could help fill this gap. Second, data gap. GNS signal GNS signal instability in densely built area cause incomplete data affecting map quality. Enhancing GNSS reception or using supplementary device can mitigate this issue. Third, restricted area. Data collection in border or restricted zone is difficult. Requiring legal and international cooperation, overcoming these challenges through technology and collaboration will improve 3D map and expand their application. The 3D map is a visual the 3D map is a valuable tool for autonomous system and simulation. This supports key functions
Interrupt
such
you,
as
ma'am. Sorry to interrupt you, but you have 2 minutes to conclude your presentation.
yes, it supports key functions such as route planning, obstacle avoidance, and reliability enhanced in enabling stable operation even in complex environment. Data from marina and pier play a critical role in high-risk docking and route optimization, reducing operational time and fuel consumption while improving safety. This map integration with real-time data further enhance performance, ensuring system operates optimally with the latest information. In summary, the 3D map enhances safety and efficiency not only for autonomous vessels but also across the maritime industry. Its potential application in marine exploration and environmental monitoring open new possibilities for innovation in various fields. This is the end of my presentation. If you want to discuss further or contact our team, please contact us by email. I hope my presentation has sparked at least a little interesting in the maritime industry among you. Thank you for your attention.
Thank you so
Yeah.
much for your presentation. Ma'am, do you have any questions?
Yeah, I can ask her a question. What algorithms did you use for? Can you go on your discussion slide? Can you hear me?
Oh yes, I can hear you.
Okay, just tell me what algorithms were used for security purpose.
For security purpose. Actually, this study is the initial process. So, for security purpose algorithm, I didn't in this step I didn't think about that. But after after step, I will check about the security of the data. Yes,
Okay.
thank
Okay,
you.
that is it. All the best for your presentation. Further research work. All the best.
Yes, thank you.
Thank you so much for your presentation. So we'll be moving on to the next presentation now. Next, we have Geeta to present the paper titled Advancing Blended Learning Strategies, a machine learning model for predicting student success. Are you there?
Hello?
Yeah, you're audible now. You may please begin with your presentation.
Yes, I can't share my screen.
Yeah, you can share your screen now.
It's
Yeah,
okay? You can see my
yeah,
screen?
yes, you may start.
Good morning, everyone. So my name is Rita Skat, and I'm glad to present our research titled Advanced Blended Learning Strategies, a machine learning model for predicting student success. This work was conducted in collaboration with Professor Selwa Firdausi and Hind Qbaili. So here is what I will cover today. So first, I will introduce the context, the research problem, and the objectives. Then I will present the literature review. Next, I will explain our methodology and present the results. And finally, I will conclude with the implications and the future perspectives of our work. So to introduce, so we can say that the COVID-19 pandemic led to more online learning, making blended learning more popular. So while it offers flexibility, it can also create some challenges, like keeping students engaged and helping them to succeed. This increased also interest in the educational data mining, which uses data to predict students' performance and support those who need help. So our research addresses three main questions. How can we predict students' performance in a blended learning environment? What are the key factors influencing students' success or failure? And the last one, how can we identify at-risk students to provide them with personalized support? So our goal is to develop a machine learning model to predict students' performance in blended learning. So specifically, we aim to analyze key factors affecting success, to identify at-risk students for targeted support, and integrate a predictive tool into educational systems to enhance teaching intervention. So concerning our literature review, we identified three key factors influencing blended learning performance. The first one is the academic factors, such as past performance and quality of teaching materials. The second one is socio-economic factors like family support and access to technology. And the last one, behavior factors, including motivation, time management, and feedback. In
Geeta.
our Yes.
Hello, Geeta. Your slides are,
Yeah.
please move your slides. They are not moving.
I'm sorry. I can let them like this because I think there is a problem to.
You should share your entire screen and then do the PowerPoint presentation. Actually, it's just showing the PowerPoint screen.
Okay. Now we can see my screen.
Yes, I can see your screen. Screen is visible. But earlier
Okay.
slides were not moving.
Now?
Yeah, we can see your screen, but please, whenever you move the slides, keep in mind that they're moving.
Yes, I moved them back. I don't know why they don't move.
Okay, it's okay. Now we can see them
It's
moving.
okay. So, concerning so in our study, we analyzed several machine learning model to predict students' performance in blended learning. And random forest emerged as the most suitable model due to its high accuracy and robustness. It reduces overfitting by combining multiple decision trees and effectively handles mixed and missing data. So, compared to other models studied like logistic regression, SVM, and KNN, it demonstrated a superior predictive accuracy. So, this model helps identify at risk students early, enabling targeted intervention to reduce dropout rates. So, we developed 5 hypotheses. The first one is past academic performance significantly influences final final performance. The second one, family support and socio-economic status impact student success. The third one, the random forest model can accurately identify at-risk students. The fourth one, students with low engagement are more likely to fail. And the last one is normalizations and the categorization of variables improve the model accuracy. So concerning our methodology, our datasets come from the University of California, Irvine, with the 642 instances and 32 attributes, including social, economic, personal, and academic factors. We processed the data by converting categorical variables, normalizing the data, and categorizing grades into low, medium, and high. And after testing several algorithms, we choose random forest, which achieved 98% accuracy. Our results show that the random forest outperformed our models. So the most influential factors were previous exam performance, G1 and G2, which strongly correlates with the final performance, G3. The number of past failures which negatively impacts performance, and engagement in academic activities where low engagement increases the risk of failure. So we also observed that class imbalance with more students in the low performance category. So let's briefly validate our hypothesis. So for the first one, we can say that effectively past academic performance is key predictor of success. The second one also is partial validated. So socio-economic factors can have some impacts, but less than academic factors. Random forest reliably identifies at-risk students. Low engagement increases the risk of failure. And the last one, the normalization and categorization can improve the model accuracy. So, concerning the practical implication and limitation, so our model had some practical implication. It enables targeted interventions like tutoring and mentoring. It can integrate into learning management system for real-time monitoring. So, however, there are limitations. So, the data set is relatively small. There may be biases due to unequal access to technology from students, and qualitative factors like motivation are really hard to measure. So, to conclude, in our study, propose a machine learning model to predict students' performance in blended learning. So we identified the key factors influencing success and develop a tool that can be integrated into an educational system. So for future work, we can plan to improve the model with more diverse data, to integrate temporal variables to track long-term trends, and to deploy the model in real educational environments to assess its impacts. So thank you for attention.
Thank you so much for your presentation. Ma'am, do you have any questions?
I have a question or a comment. It's Cornay van Staden here from South Africa. So I'm also working at a open distance learning institute in South Africa. We have 380,000 students. So I must commend you on the study. It's really very interesting. And we struggle with a similar problems with getting the students involved. So my question to you is, did you consider the participation of students in activities as part of the at-risk students? Because in our country as well, we are required to report on and identify at-risk students. So your model, will it be able to tell the lecturer, these are the students? Thank you. Well, congratulations as well.
Thank you. What we consider is the concerning activities. No, we are not considering it. We consider academic factors related to past performance and quality of teaching materials. So it can be a factor that we can add to ameliorate our research.
Thank you very much.
Thank you.
Thank you.
And ma'am, do you have any questions?
No, ma'am has already, professor has already asked. Thank you.
Thank you. So we'll be moving on to the next presentation now. Next up, we have Huang to present the paper titled AI Technology in Auditing and Financial Error Detection. Are you there? Are you there? So moving on to the next presentation, we have Asma to present the paper titled Hybrid Methods for Detection of Blood Cancer Images Using Support Vector Machine. Are you there? Asma, are you there? Okay. So we'll be moving on to the next presentation. Next up, we have Canary to present the paper titled Identification of Key Barriers to AI Adoption for the Construction Sector. Are you there? Are you there? You're not audible, Canary. Canary Kate, you are unmuted.
She's
Can you?
there. Yeah, she's there, but we cannot hear.
Yeah, can you please unmute yourself? I guess there might be some issue on her side. So we'll be moving on to the next presentation till then. We have Ivan to present the paper titled Real-Time Fault Detection with Transformers on a Customized System on the Chip for High-Speed Efficiency. Are you there? I can see you. Are you there? Yeah, he's there in the meeting. Can you please unmute yourself and begin with the presentation?
Excuse me, did you call my name? My name is Canary Kate.
Yeah, I did call your name, but you're not available.
I'm
Yeah,
sorry, I will maybe missed you.
it's okay. You may please begin with your presentation.
Yes, I'm ready. Thank you.
Please begin.
So I would like to share my screen right now.
Yeah, you can share your screen right now.
Okay. Sorry.
Yeah. You may please begin with your presentation.
Okay. First of all, good morning, everyone. My name is Canary Kate. I am a PhD candidate from Institute of Technology of Cambodia and University of Brussels. So, my thesis is focused on a proposed guideline to implementation BIM in Cambodia. Today, I would like to present my research result entitled Identification of Key Barrier to BIM Adoption for the Construction Sector, specificity to Asian. I cannot. Do you see my slide move?
Yeah, we can see your slides moving.
Okay, thank you. This is my table of content. I have 7 points today. So before begin, I would like to introduce the building information modeling is the model that has all information about the building. The building information modeling will facilitate cost control, time management, quality control, performance, and improvement in project management. So BIM has been a central subject of discussion and attention from construction professional and scholar in the past decade. There are many studies about the barrier in adaptation BIM in the construction project worldwide, including in the development country and also in Asia. But for the potential strategy to BIM adapt is to direct investment toward information technology and research. Otherwise, we can see the main research area for BIM in Europe and United States. And for in Asian, we can see only in China, South Korea, and Malaysia. That is remain the research gap for exploring BIM barrier in the Asia. So that's why my research question is to study on the contact Asian cluster, which is Cambodia, Thailand, Vietnam, Laos, Indonesia, Philippines, Singapore, Brunei, and Myanmar, China, Japan, and South Korea. So this is my research question. What is a barrier to adapting BIM among Asian plus 3 country member? So this is my methodology. I start search the article from the search engine Scopus with a keyword building information modeling, building information model, or building information management, or BIM, and barrier, or challenge and adoption, or implementation, and country by putting one by one country that I mentioned it before. So for the year publication limited to 2013 to 2023, and all the document is the journal article with in English language. So in the result, we get 81 journal article. After that, I screen out all the article and selected only article that related with my purpose. So we get 32 article. With the 32 article, we extract the barrier statement from that article. So we get 2038, and with the barrier statement, we can see the many keywords about the barrier, BIM barrier, and I group all the keywords by this following. For example, so the word awareness, knowledge, or understanding. So we group into the keyword knowledge. Another example, use apply application is grouped into the use. So from you can see all the group of the keyword. I don't go into detail on it. So you can see on my slide. After that, I put on the keyword in the NVivo software and analyze the word frequency. So the result, we can see the potential keyword that has the high frequency, which is cost, knowledge, technology, standard, training, software, change, legal, workflow, demand, collaboration, expert, hardware, organization, tool, guidance, intellectual, regulation, and use. So we match all the keywords with the various statement. In the result, we get 45 main various statements, and we classify the main barrier into 6 classifications. The cost classification is mean the issue concerning expense and time or location. Technology is the barrier associated with the technology issue that software developers should consider. People is the issue related to human attribution such as mindset, short pattern, habit, and knowledge. And environment is about the eternal concern, including issue related to standard, regularity, guideline, and regulation which fall under the government purview. So we can see the classification environment has the high frequency among the 6 classification. That means the need of the standard, guideline, regulatory, and the regulation for each country. So this tableau is showing about the 45 barrier that I mentioned before with the classification 6 classification. You can read on my slide. I will move on to another. So the result from the analyze work frequency in China, we can see the word knowledge, technology, and another is cost, change, and standard, etc. And in the Vietnam, we can see standards, legal, design, change, guideline, investment, regulation, intellectual. And in Indonesia, we can see software, knowledge, cost, hardware. And in Malaysia, it's about cost, training, technologies, knowledge, software, workflows, and with standard organization, etc., etc. In the conclusion, we can conclude that the literature review only found in China, Vietnam, Indonesia, and Malaysia, and it is remaining the significant research gap in other 9 countries like Cambodia, Thailand, Laos, Philippines, Singapore, Brunei, Myanmar, Japan, and South Korea. And the primary barrier to adapting BIM are high cost, limited technology, mindset, and knowledge of user, lack of guidance, issue of organizational change, and insufficient BIM education in both industrial and education sector. And factor that leading to BIM adoption in Asia is the environment, which includes national guidelines, standard, law, and regulation. So my research limitation is do not consider the literature of other search engine, and we lost the that we lost the literature from Japan and Singapore, that which are the front runner in BIM implementation across Asia, and I exclusively consider literature in English. So I think that if we consider another language in Asian country, we may find the other literature. And another one is do not consider the improvement of article in term citation. And the last but not least is I don't have the validation from the professional with this film, especially in the region that I mentioned. So my perspective is it is important to publish the BIM implementation guideline for the context of each country, and with the clear direction and establish a platform for the process, and highlight the benefit, vision, economic advantage and the return on investment to promote and motivate in the industry stakeholder, especially for promoting to the owner, and focusing on improving understanding and knowledge. And last one is to promote the BIM education in with the how to apply BIM in the practical industry. This is my reference. Thank you for your attention and welcome for a question. Thank you.
Thank
Okay.
you so much for your presentation. Oh, yeah, ma'am, please.
Yeah. So it was a very good presentation, very good systematic literature review done.
Thank you.
What
Thank
is the
you.
future work do you see in after doing this literature review and this work?
So
What
the
is your
whole
further research
methodology,
scope? Hello?
yes, the whole, hello, do you hear me?
Yeah, I can hear you.
Okay, thank you. Thank you for your question. For the future, I using the result from the literature review and the result from the review on the site. I am reviewing the BIM guideline from other country and also the guideline of the ISO. So we get all the result to propose new guideline for Cambodia context. And after that, we apply those guideline to the workshop, and we will get the data from that too. And finally, we will get a good guideline for the Cambodia context.
Okay, thank you.
Thank you, ma'am. Ma'am, do you have any questions?
Thank you.
So then we will be
I'm okay, thank you. Yeah, I think it's a very good study. It's very interesting to see the themes that emerge from the different countries. Yeah, I think that would also that can lead to another study to maybe determine why is that the case. But yeah, very interesting. Congratulations.
Thank you so much.
Thank you so much for your presentation. So we'll be moving on to the next presentation. Next, we have Evan to present the paper titled Real-Time Fault Detection with Transformers on a Customized System on the Chip for High-Speed Efficiency. Are you there?
Yes, can you hear me?
Yeah, we can hear you. You may please begin with your presentation.
Just give me a moment to share my screen. Can you see my screen?
Not right now.
So I sent the request. Oh, just give me a second. Okay, great.
Yeah.
Do you see my screen?
Yeah.
Okay, let's start. So, hello everyone. My name is Ivan Ursul. I'm from Lviv. I'm from Ivan Franko National University of Lviv, Ukraine. Thank you for joining my talk on how we are using transformer based approach for running deep learning models for real-time fault detection. So to begin with, faults are becoming a serious concern for older adult individuals for various reasons, mainly for mobility issues. With the global population aging rapidly, due to different factors, we should expect devices that would be suitable for problems like fault detection. The analysis of existing market and tools that are available there to detect faults shows that mainly traditional threshold-based approaches are used. Furthermore, tiny devices means there is a limited power and limited CPU. It gives a big challenge to how to provide a more meaningful, more AI-based approaches for fault detection. Yes, as I said, traditional approaches they are simple, but they have like a high false alarms. Even I won't name the brand, but the most popular device that it is on the market clearly states that if you have some false positives, don't they can occur several dozens of times per day, and please don't be afraid of that. This approach gives that tells us that in situations like detection of false for older individuals, it is crucial to avoid false positives. Additionally, studies for the last few years, using convolutional neural networks or long short-term memories, they do provide good enough accuracy, but they are too heavy for tiny devices. Transformers on the parallel, they are powerful for time series data, but they are typically too large and slow. They are better than long short-term memory models because of they are option to parallelize things, but still they were not studied and researched enough for this problem. So what's the approach? The approach is to use multi-sensor data, use several variants or forms of transformer architecture. Since it started in 2017, there were lots of different variations that are available here in the academics group. We do use Raspberry Pi Zero 2W, which is something in the middle. We don't talk about tiny devices like Arduino, and we don't talk about powerful devices like NVIDIA, which have GPU and they can run tons of different things that are not available there on tiny devices. So we are approaching something in the middle, like not yet powerful to run complex, heavy models, but still providing enough memory and like resources to experiment with that. So our goal is to achieve high accuracy with low latency. It is extremely important to achieve low latency because we do want to capture fall within milliseconds. Comparing to existing market products, the fall can be detected up to 1 minute, while it should be possible. It means that there is some human factor involved in there, so it's not fully automated. Right. So the data set that we used is basically our own data set, which we collected for several months. There were 29 different volunteers, up to something like 2K total events. So 1K, 1,000 falls and 1,000 activity of daily living, like walking, hiking, running, sitting, standing, and so on. We have multi-environment. We follow multi-environment approach. So we use basement, gym, backyard, office, acrobatic sports center, and so on. We did apply a noise filtering and pre-processing. First of all, basic linear interpolation, and then secondly, the Butterworth filter to filter out noises. It is also worth mentioning that apart from filtering noises, it was important to avoid filtering out false itself because they expose similar patterns to noises. So a special technique was applied to filter out, to avoid filtering out false activities. So we did use acceleration, magnitude, tilt angle. Right. Then we used three variations of transformers. First of all, the standard transformer, which is 2 layers, hidden dimension, a vector of 128. Then we used performer, which is considered to be the lightest model. It is our hyperparameter search concluded that it's possible to use a single layer a hidden dimension of 8 and low latency approach, which is 34 milliseconds. And then Linformer, which has low rank attention, hidden dimension. The hyperparameter exercise showed that hidden dimension can vary, and pretty much the same accuracy would be for different hidden dimensions. But then we have a balanced performance, like 110 milliseconds. So just to clarify things, when we are talking about collecting the sensor data, we are talking about collecting 8 seconds interval, basically on 10 hertz frequency, which means that we are giving 800 records of time series data to the model, which is an input of the model. Before that, we apply data preprocessing, linear interpolation, and Butterworth filter. Then we do the hyperparameter search exercise for those 3 models. We choose the best model and we use it for fault detection. So why Raspberry Pi Zero 2W? It is very small. It has enough CPU and RAM. It has 512 megabytes of RAM memory. It is also, it should be interesting to hear that all models were more like something from 200 megabytes to 400 megabytes of allocated memory. We used 2 sensors, MPU 6050, which is accelerometer data and gyroscope. It's inertial measurement unit sensor. And then we also have barometer for further studies, just to to capture altitude changes. So it is considered to be a next step in our research. We connected power, so the device can actually be embedded and can be used in various exercises and activities. And we printed a case for this. Then this allowed us to collect more data comparing to existing studies where there's fewer number of records available, and it's smaller than our data set. So the result is that in terms of accuracy, transformer is considered to be the best. Traditional transformer is considered to be the best architecture. However, it has the bigger size, and the latency is quite huge. It's the biggest latency that we could capture. Then performer has low latency but bigger accuracy, and like let's say something in the model size is something in the middle. And then the Linformer has something like a trade-off latency, but it's relatively the same model accuracy. So our choice is the performer, which is the best trade-off because of the lowest latency. It is extremely important in terms of tiny devices, system-on-chip devices like Raspberry. So our key takeaways is that we showed that it is possible to run transformer models on very tiny devices. It is, however, there are several challenges, but we were able to fight them. It has a real-time inference, like 34 milliseconds, and has a good accuracy, which shows that probably further studies and generating further studies with larger data sets would probably give a good enough latency for us, good enough accuracy for us to run on those tiny devices. So our next steps, future directions are to optimize our models even more. In particular, apply quantization and pruning. This would be extremely useful for devices like Arduino, like basically microcontrollers, not system-on-chip devices. So we also do want to have barometer data. So our next data set will contain this data. And we do want to have a larger, more diverse user studies. I guess that's it. Any questions?
Thank you so much for your presentation. Ma'am, do you have any questions?
Yes, it was a very good presentation,
Thank you.
and a very interesting one. So,
Thank you.
which algorithm are you planning to use for pruning purpose?
We don't know yet. We don't even know if we want to use microcontrollers, mainly because the analysis of existing literature shows that like pruning or quantization reduces the accuracy in terms of 10%. At least this is something that was achieved on researchers from all around the world. So there's a question whether we should go with this in the middle approach and concentrate on the system on chip devices, which is getting more and more development over all around the world, or should we go with microcontrollers? I guess the question is, I guess we will go with the former one because it's more.
I
It is.
suggest you should just not talk about accuracy. You should also consider the carbon footprint while selecting the model. Because if
Yeah.
you'll just work on accuracy, it might
Yeah.
just be more heavier on carbon footprint because you are thinking about the tiny devices, isn't it?
Right.
So
No,
that is one point.
we're choosing between microcontrollers, which are also tiny devices, and
Yes.
system on chip, which are more powerful, but in practice they are
less on carbon consumption.
Could be, yes.
Yeah. Thank you.
Okay, thank you.
All the best.
Thank you, ma'am.
Thank you.
All the best.
Thank you.
Okay, so I guess no questions. So we'll be moving on to the next presentation. We have Asma Abdul Razak to present the paper titled Hybrid Methods for Detection of Blood Cancer Images Using Support Vector Machine. Are you there now?
Yes. Yes.
Yeah, you may please begin with your presentation.
Yes. Our screen is visible?
No, not yet.
Invisible?
No, it is not visible.
It's visible?
No, it is not visible.
1 minute.
Can you please reshare your screen? Then maybe it might get visible.
Yes. Now, is visible?
Yeah, you have started sharing screen. It is visible now.
Yes. Welcome. My article focus on hybrid methods for detection of blood cancer image using a support vector machine. Please 1 minute. Something wrong? Yes.
Yes, it's visible.
Okay, abstract. Leukemia is a cancer also known blood cancer, is a deadly type of malignancy in human that has the blood, bone marrow, and lymphatic tissue in its scope. Recent trends in the development of machine learning, especially support vector machine, has shown a great potential in medical imaging classification. This paper proposes software application classified by blood analyzing using blood cell as an input. Feature extraction is accomplished using 3 approaches: fractal, run length, and hybrid between them. Features which are then used to build support vector machine model. Evaluation module were done in terms of accuracy, confusion matrices, and comparison with the other similar studies. A fractal feature were obtained in the support vector machine model at the accuracy rate of 0.70, but run length feature accuracy of 0.86.
When I then mix the two methods, hybrid feature achieved as accuracy of 0.89 by combining feature extraction technique. Methodology. The dataset used in this study comprised image of cells blood in two classes, namely healthy and cancerous cells. A proportion of 30% was identified as the testing group, while the 70% was identified as the training group. Developing support vector machine was done on the training data, whereas models were evaluated on the testing data. Feature extraction. In this study, three methods were employed to extract feature from the image of blood cells. The first method is a fractal feature. This method was used to provide a mathematical description and process of explaining complex design repeated at the varying size for graphical models of the fractal feature incompleteness composing the structure of cell. The second method is run length feature. This method was used to capture patterns related to the distribution of pixel intensities in the image for texture analysis. When I mix the two methods called hybrid feature, fractal and run length, here both of complexity and the texture of the cellular structure are captured. The hybrid approach seeks to combine these features to improve the classifier in the term of a class discrimination of the healthy and malignant cell. Are your screen visible?
Yes, it is.
The result and discussion. When I use a fractal feature with the support vector machine, the result obtained from this method depending on the histological properties of the tissue. In a fractal feature, with the support vector machine attained accuracy of 0.70. The mean square error explain the vertical axis, and then the number of epochs explain the horizontal axis. This shape explain the confusion matrix for the method. In the second method, I use run length with the support vector machine. In this method, feature performed better with an accuracy at 0.86 and confusion matrix more balanced performance because run length captured texture patterns in the image and mean square stayed relatively low. When I mix the two methods, fractal feature and hybrid, run length feature with the support vector machine. In this method, mean square error is lower compared with the fractal graph, and the model of stabilized quickly. Conclusion. This study confirmed the effectiveness of support vector machine discriminative feature in the detecting blood cancer image and the result classifier. Efficiencies for different feature uses from the finding of this study. However, it was observed that the best performing feature set was hybrid one. The combination of both fractal and run length feature, which recorded an accuracy of 0.91, is point to the necessity of utilizing different techniques to extract features from medical image to obtain the complete data set required. Thank you very much. If you have any question.
Thank you so much for your presentation. Ma'am, do you have any questions? Okay, do we have any questions?
I'm not sure. I'm just going to ask, so this detection of cancer cells and cancer, will it be done in the early stages, or is it when the person goes to the doctor, blood is extracted, then it's put through this SVM, and then you detect the cancer? So at what stage will you be doing that?
With me? I can hear. Please.
The question is, at what stage will you be using this when person goes to the doctor and they draw blood? So the comparison of the blood and the detection of the cancer. At what stage will it happen?
I use samples of image and perform the pre-processing on the image and compare with the diagnosis of the doctor.
Thank you.
Thank you.
Thank you so much for your presentation. I guess no further questions we have. Okay. So, you may please stop sharing your screen. So, do we have Huang to present her paper? Do we have Huang? Okay. So we will be ending this session. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for each one of you. We, on the behalf of the whole team, thank you for your support during this 10th version of the conference and all the previous 9 versions. We will be happy to have you in the 10th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the printer. The publication will be live within 6 months, so kindly cooperate with the team of ICICT 2025. Before ending this session, I would also like to take a moment to thank our session chair, Professor Con John Van Stan, for chairing this session. Thank you so much, ma'am. Would you like to share a quick closing remark with us?
I just want to congratulate the colleagues with their the research. It's very interesting to always attend a conference where people are representative all over the continent, and the amazing work that you're doing, and the thought-provoking studies that is coming out, and the interconnectedness or integration of machine learning and blood cancer detection, for example, or combining exercises with machine learning and computer science. We are really taking the world forward with IT. And I just want to congratulate the colleagues on that. Keep up the good work. And even with the student at risk management, if we are at risk students, identification of them, if you can find a solution that we can use in the whole of the world, it will really help. Thank you.
Thank you so much, ma'am, for chairing this session. I would also like to take a moment to thank Dr. Anubha Jain for chairing this session. Thank you so much, ma'am. This is a token of appreciation to the chair on the behalf of whole team of ICICT 2025 and Global Knowledge Research Foundations and partners. We would be really glad if you could share a quick closing remark with us.
Thank you, Anisha. Thank you very much. As usual, the session was wonderful, and we had a very good set of researchers with us. So, GR Foundation is doing a great work, providing a global platform for all the researchers. So, I congratulate all the organizers and I wish luck to all the researchers. And I thank my session co chair also for being there. Thank you.
Thank you so much, ma'am, for your valuable presence. Before ending the session, I would request everyone to please turn on your cameras for a quick snap.
Thank you.
Thank you so much
everybody.
for your valuable presence. Take care and
you.
stay safe. Thank you. Bye-bye.
Thank you very much. Bye.
Hello, Professor.
Hello, and how are you? I just responded to your email. Yeah, it's just hectic on our end with the neck of the world, but yeah, I've responded to your email. I will assist.
Thank you so much, ma'am, for chairing the session. Thank you.
It's a pleasure. I will maybe contact you relating to last year's publication as well.
Sure, sure. Thank you.
Thank you. Bye.